So now in the next part of the lecture on artificial intelligence, overview of artificial intelligence, we get into deep learning. So in deep learning, there is artificial neural networks, which are computer systems inspired by the human brain's networks of neurons. Then there are convolutional neural networks, which are artificial neural networks especially good at understanding images. Then recurrent neural networks. These are designed to handle sequences like sentences or time series. Then in recurrent neural networks, we have long short term memory. LSTM neural networks is a type of RNN that can remember information for a long time. And then there are gated recurrent units, which are simpler version of LSTMs. Now there are transformer models in deep learning, which are advanced models that process data in a way that allows parallelization, great for language tasks. Now self-attention mechanisms. Self in transformers, the self-attention mechanism, the model focuses on different parts of the input data when making decisions. And then there is BERT, BERT. It's a model that understands language in both directions. And then there is GPT series, which can generate human like text. Now there are autoencoders. Autoencoders are models that learn to compress and decompress data. Learn to compress and decompress data. Learn to compress and decompress data. Then there are variational autoencoders. Then there are variational autoencoders that can create new data similar to the input, autoencoders that can create new data similar to the input. So there are autoencoders, that is, models that learn to compress and decompress data. Models that learn to compress and decompress data. So then there are in autoencoders there are variational autoencoders. These variational autoencoders, they can create new data similar to the input. They can create new data similar to the input. Then there are generative adversarial networks. These are pairs of networks that create. These are pairs of networks that create realistic data by competing with each other. Then there are graph neural networks. These networks that work on data represented as graphs. These networks that work on data represented as graphs, like social networks. Now there are capsule networks that understand the relationship between parts of images. And then there are deep belief networks, a type of deep neural network that learns to reconstruct the input. Then there are eco-state networks, which is a type of RNN that is easier to train. So eco-state networks, then deep belief networks, which reconstruct inputs. That capsule networks, relationships, they find relationships between parts of images. Then graph neural networks, which work on data that is represented as graphs. And these generative adversarial networks, pairs of networks that create realistic data by competing with each other. Then there are variational autoencoders, which are autoencoders that can create new data similar to the input. And autoencoders are the models that learn to compress and decompress data. Then there are self-attention mechanisms. We have learned BERT, GBT in transformers. Then the long short-term memory and gated recurrent units in RNN. Then convolutional neural networks. So these are the things that we have discussed in the deep learning aspect. Thank you. In the next lecture, we will cover the natural language processing and other things. Okay, let us continue rather. Let us continue in this lecture somewhat. Then there is natural language processing. In natural language processing, you have speech recognition. There is turning spoken words into written text. Then there is machine translation, translating text from one language to another. Then there is sentiment analysis, figuring out if the text expresses positive, negative, or neutral feelings. Then there is text summarization, which is very, very important, just shortening long pieces of text while keeping the main ideas. Then there are question answering systems, systems that answer questions posed in natural language, systems that answer questions posed in natural language. Then there are chatbots and conversational AI, which are programs that can have conversations with people. Then there are named entity recognition, identifying names of people, places, etc. Then there is part of speech tagging, labeling words as nouns, verbs, and adjectives. Then there is language modeling, predicting next word in a sentence. Then there is topic modeling, just finding common topics in a collection of documents. It's very important. Then there are word embeddings. This is also very important. It's representing words as numbers in a way that captures their meanings. This is just fascinating. Very, very, very important. So in word embeddings, there are word to wake. This is a method for creating word embeddings, and then there is globe. This is another method for creating word embeddings. The natural language understanding, it is the comprehending the meaning behind the text. Then there is natural language generation, which is generating natural language text from data. Now comes computer vision. In computer vision, we have image classification. It's identifying what is in an image. It is about identifying what is in an image. Then object detection, finding and locating objects in an image. Then the in object detection there is the YOLO, you only look once, a fast algorithm for object detection, and there is RCNN, a method for object detection using regions. Then there is semantic segmentation, leveling each leveling each pixel of an image with a category. This is also very, very interesting. Semantic segmentation, leveling each pixel of an image with a category. Then there is instance segmentation, It is differentiating between multiple instances of an object in an image. Then there is facial recognition, identifying or verifying a person from their image, from an image of their face. Then there is gesture recognition, which is recognizing human gestures like waving or pointing and other gestures. Then there is image generation, creating new images using AI. Within image generation, we have style transfer, mixing the style of one image with the content of the another. Very interesting. Then deepfake technologies, which is creating fake images or videos that look real, often used to swap faces. And there is video analysis, understanding actions and events in videos. Understanding actions and events in videos. Video analysis is understanding the actions and events in videos. Then there is optical character recognition, which is reading text from images like scanning a page from a book. Then there is 3D vision, where there is depth estimation, understanding how far away things are in an image. Understanding how far away things are in an image. How far away things are in an image. Then there is point cloud processing, working with 3D data from sensors like lidar. So now next topic is robotics and autonomous systems. So there is robotic manipulation, robots using arms and hands to move or interact with objects. Using arms and hands to move or interact with other objects. Then path planning, figuring out the best route from one place to another. Then simultaneous localization mapping, robots creating a map and keeping track of their location at the same time. Robots, they are creating a map and keeping track of their location at the same time. Simultaneous localization and mapping. Then there are autonomous vehicles, self-driving cars that can drive themselves without human input. And drones and UAVs are there. So flying robots that can operate without a pilot. Flying robots that can operate without a pilot. Then there is human robot interaction, how humans and robots communicate and work together. How humans and robots communicate and work together. Then there is swarm robotics, many simple robots working together like a swarm of bees. Robot learning, robots learning in new tasks from experience or demonstration. Robots learning new tasks from experience or demonstration. Then there is medical robotics, which are robots used in healthcare, like for surgery or for rehabilitation. So, medical robotics, then for surgery rehabilitation, robot learning new tasks from experience or demonstration, swarm robotics, many simple robots, human robot interaction, drones and UAVs, self driving cars, and autonomous vehicles. Simultaneous localization mapping, robots creating a map and keeping track of their location at the same time. So these are the topics.